Welcome back, everyone. Today, we're embarking on a detailed journey through the human body, focusing on three crucial elements: muscles, bones, and joints. These aren't just random parts, they form a complex network that allows us to move, stay upright, and protect vital organs. We're diving deep into each type of muscle, bone structures, and joint classifications to truly understand how they function together. Let's begin. First up, let's talk about muscles. Did you know that the human body contains over 600 muscles? Each one is meticulously designed to perform specific functions, from the fine movements of your fingers to the powerful contractions of your heart. Muscle tissue consists of contractile cells, often referred to as muscle fibers. These fibers are the building blocks of muscles, and they work by contracting and relaxing. Now, we categorize muscle tissue into three main types: skeletal, cardiac, and smooth muscle. Skeletal muscles are attached to bones and are responsible for most of the body's movements. Think about every time you walk, wave, or lift something heavy. That's your skeletal muscles at work. These muscles are under voluntary control, meaning you consciously decide when to move them. Skeletal muscles are composed of bundles of muscle fibers grouped into fascicles. These fibers are connected to bones via tendons, which are strong, fibrous tissues. Each muscle fiber is packed with myofibrils, responsible for the muscle's ability to contract. This contraction is what generates force and facilitates movement. Moving on to cardiac muscle, this type of muscle is found exclusively in the heart. Unlike skeletal muscles, cardiac muscle is involuntary, meaning it functions without conscious thought. These muscles contract rhythmically and continuously, pumping blood throughout the body every second of every day. Cardiac muscle cells are unique. They're branched and interconnected by structures called intercalated discs. These discs allow electrical impulses to pass quickly across the muscle cells, ensuring that the heart contracts in a coordinated, wave-like fashion. Last but not least, we have smooth muscle. This muscle type is found in the walls of blood vessels and hollow organs, like the stomach and intestines. Smooth muscle cells are spindle-shaped and, like cardiac muscle, are also involuntary. They play a vital role in moving substances through the body, such as pushing food through the digestive system via peristalsis. Smooth muscle contraction is controlled by the autonomic nervous system, meaning we don't have to think about digesting food or controlling blood flow. These muscles contract slowly and can sustain contraction for extended periods without tiring, unlike skeletal muscles. Muscles aren't just defined by their type, but also by their shape, which directly relates to their function. Let's break down some of these shapes to understand how they serve the body's needs. Flat muscles have fibers running parallel to each other and are often associated with a broad, flat tendon called an aponeurosis. The external oblique muscle is a classic example. It covers the abdomen and helps with trunk rotation and lateral flexion. Quadrate muscles are square or rectangular, typically featuring 4 equal sides. The rectus abdominis, your six-pack muscle, is a prominent example. It plays a crucial role in flexing the lumbar spine, allowing us to bend forward. Pinnate muscles have fibers that attach obliquely to their tendons, much like a feather structure. They are designed for strength rather than speed. These muscles can be unipinnate, bipinnate, or multipinnate, each serving different functions. Fusiform muscles are spindle-shaped, with a thick belly tapering towards the ends. The biceps brachii is a perfect example, providing a combination of force and speed for forearm movements. Multi-headed muscles, like the biceps brachia and triceps brachia, have multiple origins or heads that converge into a single tendon. Multi-bellied muscles, such as the gastrocnemius and digastric muscles, have more than one muscle belly, providing additional strength and endurance for tasks such as chewing and leg movement. Convergent muscles have a broad origin that converges onto a single tendon. The pectoralis major is a great example, originating from the clavicle, sternum, and ribs, and inserting on the humerus, allowing for powerful arm movements. Finally, circular muscles, or sphincters, form rings around body openings, controlling the passage of substances. The orbicularis, oris, around the mouth is a prime example, enabling actions like puckering your lips or whistling. Now that we've covered muscles, let's delve into bones, the rigid framework of the body. Bones are categorized by their shapes, each designed to perform specific functions. Long bones, like the femur and humerus, are crucial for movement and support. They have a long shaft, known as the diaphysis, and two ends, called epiphyses. The metaphysis is the flared part of the bone between the diaphysis and epiphysis, and it houses the epiphyseal plate, or growth plate, in children and adolescents. Short bones are cuboidal and provide stability with limited movement. They're found in areas like the wrist, carpals, and ankle, tarsals. Flat bones serve as protective shields for vital organs and provide surfaces for muscle attachment. Think of the skull protecting the brain, or the ribs safeguarding the heart and lungs. Sesamoid bones are embedded within tendons to protect them from stress and wear. The patella, or kneecap, is the most well-known sesamoid bone, enhancing leverage during knee extension. Irregular bones have complex shapes that do not fit into any other category. They often have multiple functions, like the vertebrae, which protect the spinal cord and support body structure. Bones aren't just simple structures, they feature various markings that serve as sites for muscle attachment, joints, and passages for nerves and blood vessels. Let's break down these markings. Depressions and holes like notches, foci, and foramina allow nerves and blood vessels to pass through or alongside bones. For example, the foramen magnum at the base of the skull allows the spinal cord to connect with the brain. Extensions and projections like tubercles, spines, and crests serve as attachment points for muscles and ligaments. The greater trochanter of the femur is a prominent example where multiple muscles attach. Now let's move on to joints, the connections between bones that facilitate movement. Joints are classified based on their structure and the type of movement they allow. Fibrous joints are connected by dense connective tissue, allowing little to no movement. So, sutures between the bones of the skull are classic examples, providing a solid, immovable structure. Cartilaginous joints are slightly movable and are connected entirely by cartilage. These joints, such as the pubic symphysis and intervertebral discs, absorb shock and provide flexibility. Synovial joints are the most common and freely movable type of joints in the body. They are characterized by a joint capsule, synovial fluid, and articular cartilage covering the bone ends. These features facilitate smooth and frictionless movement. Synovial joints come in various forms, each allowing different types of movement. For instance, hinge joints like the elbow allow flexion and extension, while ball and socket joints like the hip and shoulder allow for a wide range of rotational movements. Ligaments are tough bands of connective tissue that connect bones to other bones, providing stability and guiding joint movement. They are crucial for preventing excessive movement that could lead to injury. Joints are also well supplied with blood vessels and nerves. The articular arteries provide essential nutrients to maintain joint health, while nerves offer pain signals and proprioceptive feedback, helping us maintain balance and coordination. So there you have it, a comprehensive look at the muscles, bones, and joints that make up our bodies. These structures work together in perfect harmony to allow us to move, maintain posture, and protect our vital organs. Understanding how these components function can help us appreciate the incredible design and capabilities of the human body. If you enjoyed this video, please give it a thumbs up, share it with your friends, and don't forget to subscribe for more in-depth anatomy and physiology content. Also, make sure to check out King of the Curve for more interactive learning tools and resources to enhance your studies. Thank you for watching, and good luck studying.